BAC minus EAC, estimate at completion. We'll work this one. I'll show you how to work this one out. If I could project, if I could tell how much the project will cost at the end, do an estimate of the project cost at the end, I could compare that to the budget and tell the variance at completion. When we finish, what will be the difference between our budget and what we actually incur? Okay, that's the variance at completion. So if the budget is 1,000 and we do our forecast, and we think that when the project is done, we are likely to spend 1,002, our variance at completion will be minus 200, which is negative. Negative is bad, which means we are likely to go over budget by 200 cedis. Okay, this is what you do as a project manager. Remember, we said that many people may disagree, but that's the truth, especially in our part of the world. The most important thing that project managers are supposed to do is monitoring. Most important, we didn't say planning is not important. We didn't say performing, making sure they perform the job is not, or performing part is not important. Closing is not important. We are saying the reason why we bring you there, the most critical reason that we will find you, we look for you, is monitoring. Because you're a manager, you're a supervisor. We've talked about this. I shouldn't labor the point. So here, you need to forecast, look ahead. You are monitoring, you look ahead. You see what is happening, and that could inform what could happen. Now we have target. In my space, in my organization, we have targets. We have target for the year. We break it down into monthly target, break it down into weekly target. So every week we have our target. How many pallets we have to do, output, we check all these ones. But I keep telling my managers, you don't need to wait till the end of the week to tell whether your target will be achieved or not. You need to forecast. Day one, day two, you should have a clear picture of what will happen at the end. If you don't like what you see, act. So it's called gauging and acting. So you need to gauge ahead. You are looking for raw materials. So you think if you could get this volume of raw materials, you should be able to finish about 500 pallets for the week. Day one, day two, day three, raw materials not coming in. You're not hearing from your vendors. That should tell you something. So you could use this to forecast. You don't like the picture, it's likely you won't achieve your target. But you don't like the picture at the end. So what do? You act. What do? You need to find alternatives. So who could be an alternative vendor? Look for other options. What can we do? There are instances where we may have to send some raw materials from one side to another side in order to basically get a target. You need to forecast, and it's a great skill. Forecasting is a great skill. So here, the project manager will have this name. Project Prophet. He's a Project Prophet. Okay. I'll bring you other names. I think we already heard the Project Steward. Project Prophet. Have you heard the Project Integrator? We talked about it. He integrates everything. He puts everything together. As we go, I'll bring you another one. He's a Project Greek Argos. Okay. Argos, there's a story there. I'll tell you about it. Okay. Argos, the Greek Argos, if you look into history, Greek history or Greek mythos, stories, this will come up. There was a guy called Argos. And Argos was a giant. with 100 eyes. And he was taught to guard the goddess Hera. So there was a goddess called Hera, and the giant was tasked to guide the goddess. Now, you could imagine how his work would be that easy. He's got 100 eyes, and he's a giant, thick, tall, 100 eyes. You could see practically everything that's going on in the city. So you could tell that the goddess was in good hands. And we know if you are being protected by God, that's when you are in good hands. Anything could happen. Yes. So what we are trying to say is when you have a project manager who acts like an Argos, great Argos, supervising, checking exactly what happens, protecting the project is in good hands. So you need to be a Greek Argos. You need to be a great supervisor. You don't have 100 eyes, do you? But you could have 100 eyes. How do you have 100 eyes? Using the methods that we've been teaching you. We'll talk more about it, things you use to monitor and control. So you need to create all these ones, feedback paths. You need to basically use other methods, use AIA, artificial intelligence assistant. You could use visual management tools are part of AIA. You could use software to help you do this. You could use information radiators to help you see exactly what's happening. Dashboard, some people use CCTV. That is like you having 100 eyes. So you know exactly what's happening. And that is the project Greek Argos. You need to be a Greek Argos in your project. And I'm teaching my managers to be Greek Argos using some of the techniques that we talked about. So looking at this, I also mentioned, I didn't forget, indicating, leading indicator, and lagging indicator. Now your CPI, what type of indicator is this? Is it a leading indicator or lagging indicator? Do you remember the meaning? Leading indicator, do you still remember? Yes, anybody to pick it. What's a leading indicator? What's a lagging indicator? I won't spend too much time. There's a lot to do here. If you don't remember, I'll skip. We just go. We've done these ones. All right, great. Let's move. Let's make some progress. CPI is a lagging indicator. Okay. When it happens, it tells you things that have actually happened in the past. That's a lagging indicator. What tells you things that could happen in future? That's a leading indicator. So this variance at completion is telling us what could happen in future. So that becomes a leading indicator. It's a forecasting indicator. It helps us forecast. Okay. All right, great. So that is something you need to know. You could also sketch this to know exactly what's happening to your project. So you have a curve. But remember this, watch this. There are some questions on this. This is the planned value. So this is the ideal situation. It's been marked nicely. We wish that a project, everything happening will fall on this path. But things won't just go smooth like that. Things will happen. But watch, whenever you have your EV below the curve, that's a problem. It means you are earning less. And whenever you have the EV, you also need to sketch your actual, what's actually happening in terms of actual cost. But when you have the EV below your AC, you also have a problem. So this one tells one story. When your EV is weak, there's always a problem. You always want to have a strong EV compared to your PV and AC. So if you sketch, if you plot, and your EV is weak, the project has a problem. If you want to know what's happening with regards to your schedule, you look at where the EV sits and where the PV sits. If the EV is below or weaker, it means there's a problem. Let's look at this measurement date here. This is a measurement date. Our 30th May is here. At that time, we will link it to our cost. EV is somewhere here, 200. PV is up, say 300. AC is somewhere here, say 400. Now look at this. Your EV compared to your AC is weak. You have spent 400. You were supposed to spend 200. That's a problem. You have performed about 200 of the work. You're supposed to perform about 300 of it. That's a problem. So you are performing less than what you are supposed to perform, and you are spending more of what you are supposed to, more than what you are supposed to spend. That's a problem. So this is what you could use to tell the story, tell the situation in the project. You look at where your EV sits. If it's you're looking for schedule, compare that to your PV. If it's below, if it's weaker, then there's a problem with our schedule. We are behind schedule. You compare with your AC. If it's lower, below, it's weak, you are overrunning your budget. But if your EV is strong, is above the PV, it tells a different situation, story. It tells us you are doing well. You are doing well. So always look at where your EV sits. Your EV is your power. If it's good, you are good. If it's not good, you are not good. All right, now let's look more at forecasting indicators or leading indicators. One major thing you need to know as a leading indicator is EAC. You usually will have questions on this, so you need to know how to calculate this. Pay attention here. You need to understand how to calculate this. It's not too difficult, and I'll paint a picture for you to understand it. Now, look at the whole project. You are moving from A to Z. You've gone up to D. You've done up to here, D. So once you've done up to here, what can you get? You can get EV performed. You can also get AC. So up to this level, you've spent about this AC. That's 100. From the project from A to Z, budget is 2,000. A to Z, 2,000. You've done 100. Now, estimate at completion. I'm here, but I want to know how much we are likely to spend. I just would add how much I've spent plus how much I'm likely to spend from this point to Z, from D to Z. And I could work this one out. So this is what we call ETC, estimate to completion. So at that point to completion, what could be the estimate? This is your ETC. So looking at EAC, if I want to get a forecast, it would be EAC equal to, if I want to get a forecast, EAC will be equal to AC plus ETC. So I know exactly what happens. So if I know 100, I need to work this one out. ETC, work it out. Have the budget, have my EV, what I've spent so far, according to EV. So if I have the budget, deduct my EV, I should get my ETC. Okay, and that will tell me how this is done. Okay, so with this picture, let's look at other methods. So the general calculation for this is that EAC is equal to AC plus ETC. I'll break it down and get this understanding, this one, and also get other ways of computing the EAC. So in exam, you need to pay attention to the question. Some people won't pay attention to the question. They'll use one formula, get an answer, think they are right. You have all these ones, all the other ways of calculating it. The answers will be in there. So once you use one method, you still get an answer. So he said, I got an answer, but they marked me wrong. No, it's not about getting the answer. It's about understanding the question, knowing the right formula to use. Great. So if you want to calculate the EAC, and the question says, assume the future work will be accomplished at the planned rate. Then you're looking at this. So here's a picture. This diagram. This is the project. These are the major things you have to do. This is A, this is B, this is C, this is D, this is E. Now, at that measurement date, you had done A and B. So, and. This is not done, this is not done, this is not done, not end. Okay? Now, if you put all of them together, you have the total budget for the project. Call it 2,000. You've done A and B, you have what? End value. So if you put them, call it 200. You want to know how much you spent so far, okay? Or you want to know how much work is left to be done and what will be the estimate. So this is your estimate to completion. If you have to finish the work, what are the tasks that you have to perform? What are their planned values? You put them together and that will be your estimate to completion. So if this is what you want to compute, you have the total budget. This will be your total PV, isn't it? So if I have this, it would be 200, which is the BAC, 2,000 minus 200. So the total budget, we call it BAC. That's your budget at completion. So this is like budget. So when you are working this and they give you the project budget, remember is the budget at completion, BAC is the same thing. When I have the budget, BAC, subtract the end value. This is done, I'll know the total for this. Okay, so this will be your ETC. Now, if I want to get the estimate at completion, I'll bring in what I've spent already. This is done. How much have I spent? Plus the estimate for this. That will be my BAC minus EV. And that will give me the estimate at completion. Did you get it? This is a whole project. We've done A and B already, so we've earned them. We can record the end value. We want to know how much work is left. So moving from there to completion, what will be the estimate to completion? So we calculate this ETC. It will just be the total budget minus what we've earned, and we'll get these ones. It's not the same. If this is A and B, we know the total budget. We are looking for what is left. We just subtract this from the total budget, will give us this. So this is the BAC total budget minus what we've earned, EV. Then you add your actual cost. I'm trying to explain it this way because many people try to blindly memorize it, okay? So if you understand it, will be better. It will stick better than you just looking at it and memorizing it. Okay, so this says if the work will be accomplished at the planned rate, use this formula because moving forward, we are looking at the planned value. Okay, so we use this formula. But what if it says if the CPI is expected to be the same for the remainder of the project? So you are moving, you got to D, and at this measurement date, we expect the CPI that you have computed, calculated to be the same throughout. From this point to completion, it won't change. Then you can use this formula. All you do is one of the easiest. All you do is to pick the budget, BAC, and divide by your CPI. So example, if your budget is 2,000 and the CPI, what's the formula for CPI? Always the EV first divided by AC. So if your EV is 200, AC is 210, calculate the CPI for me quickly. I want everybody to do it. Great. 2,105. So the project profit, even though the project is not done, he says your estimate at completion based on your cost performance will be 2005. Meaning, if you don't do something to improve your cost performance, you will go over budget by 105. I was on radio last Wednesday and I gave them some figures. We had the CPI, and I was able to tell what could happen in the project. And I was just doing this to demonstrate the project profit. You need to forecast. You don't need to wait till you finish before you know whether the project will go over budget or you stay within your budget. It's something that you should know beforehand. So you become a project profit here. And what makes you a project profit is your techniques. You have these techniques, you have these tools to help you work these ones out. All right, what if moving forward, time will be important, cost performance will also be important. So we factor in our cost performance, factor in the time performance. Time is a factor in here. How do you forecast? We use this, so it comes back to this, the fundamental. If both CPI and SPI will influence the remaining part of their work, then we pick AC. We have our BAC minus EV for the remaining part of the project, and we divide all this bit by CPI times SPI. So your CPI, the combination of the two, because both will actually influence the remaining part of the work. So when they say if both the CPI and SPI will influence the remaining part of the remaining work, then you need to go back to the first one. And that bit, the ETC bit, you divide by the combined effect, CPI and SPI. Okay, for example, you have your budget as your AC as 100. You have your budget as 2,000, EV 200, CPI is 0.95, your SPI is 0.98. So you multiply, you work these ones out, okay? And that will give you EAC. What I need to be quick to say is this. If you work these ones out, the answers won't be the same. That's a task I'll give to you. That come out with your own project. You need the basic things. All you need is the basic AC. You need EV. You need PV. Just assume these ones and your budget. Then calculate your CPI, SPI, then work out the EAC using these formulae or formulas. You realize the answers won't be the same, but they would be very close. So you need to understand the question, what they are asking for. What they are asking for. You also need to be aware of this calculation. Some people write it this way, AC plus BAC minus EV, then divide everything by CPI times SPI. No, it's this only this bit that is divided by CPI and SPI. Please, if you do that, you get it wrong. And I wouldn't be surprised to see this one being worked out and put in the options to tempt you, because they think some people could work it out this way. So they'll work it out this way and give you an answer. So when you work it out this way, you still have an answer and you think you are correct. So watch it. All right, great. Let's make some more progress. They could also ask you to to work out the estimate at completion if the initial plan is no longer valid. Okay, so we've done all the way to D here. We know the actual cost. We want to get the estimate at completion, but want to compute what will happen between D and Z and R to how much you've already spent to get the estimate at completion. But you are saying the initial plan is no longer valid. So the summation of the PV won't work. It's not necessary. The project has been thrown out of gear. Lots of things have actually happened. COVID has come in, is an example. So the plan has changed. We need to re-estimate the project from this point to completion. For example, cost of bags of cement you are constructing, cost of bags of cement gone up, cost of the materials you are using gone up, unforeseen circumstances, that what you estimated it does not really is not valid again based on the things that are actually happening. You are allowed to re-estimate from that point to completion. So when that happens, you use AC plus bottom-up ETC. So from this point, we use bottom-up estimating. We'll look at the work, break it down. We already have in the work breakdown structure. Then we re-estimate costs for the various components and roll them up to aggregate them to get the cost for the remaining part of the project. I've seen projects like that. Things could go awry, things could go wrong, and moving forward, we may have to re-estimate the cost of the various elements. Okay, great.